Good morning, guys. Today we're going to continue what we started yesterday. So today, inshallah, we're going to talk about the air resistance and falling objects, or continue this part. So actually, in this part, we talk about gravity and motion. And we said actually any falling object, on once object fall from a certain height, it doesn't matter how much heavy the object is. It depends on the gravitational force of Earth. And we said we could find, or we could use the for this equation to find the velocity that the objects are falling with regarding to the gravity and the time needed until it reaches the Earth's surface. And then we answered some uh, questions that represent that always the object that fall down, they move with the same acceleration based on the gravitational force of the Earth. Then we said that air resistance, the opposition that which the object face while it's falling because of the friction with the air. So we call this that's air resistance, and it affect, of course, the movement of an object. And we said the amount of air resistance or resistance could increase once the size of the object increase, the shape of the object, the more streamlined shape the object is, the less resistance it has. And as the also the speed, once the speed of object increases, the air resistance also increases. So here then we said that, for example, this apple actually it is under two forces: the gravitational force, which attract the apple toward the earth, and the same time the air resistance, which is already moving the apple upward, or it opposes the motion of the apple. But overall, the gravitational force is more than the air resistance. So here the combination of these two forces produce net force toward the ground, or in the direction of the gravity. But of course, it's not falling with the same speed or the same acceleration in absence of the air resistance. So then here we said that also air resistance could affect an object with something we call terminal velocity. What I mean by terminal velocity? As object keep falling down from high elevation to lower, that's mean here as object keep falling. So if I have a certain object, like for example the apple which we said, and this apple, okay, are moving, falling down. So as it fall down, its speeds start to increase because it accelerates because of the gravity. So it speed up. It keeps speeding up until the air resistance equal the gravitational force. At certain moment, once the two forces are equal, the apple will keep falling down, okay, with a constant speed, and that means it will not accelerate anymore. It will reach the maximum speed and then stop. In this case, we call this terminal velocity. So here we said that as the speed of falling object increases, air resistance increases, and we find that the air resistance keep increasing until it gets equal, okay, the force of gravity. So till this moment, that will be constant velocity the object move with, and we call this terminal velocity. So here we said that also free fall object or free falling object. Could we say that is it kind of free falling? Actually, the word free falling, with some people they just put in mind when some people call they are the free diving or skydiving, that you jump from an aeroplane from high elevation with a parachute and then they keep like, we call that free falling. Actually, it's not free falling. To call it free fall, it must be in absence of air resistance. And of course, as you are in the atmosphere of the Earth, so of course you have a kind of air resistance. So it's not a free fall. Free fall just happen in absence of air resistance. That means just happen in space only. So in this case here, we said that free fall, that's once object fall down due to the pulling of gravity, and there is no other forces acting. That means there is no air resistance. And this case just happen only when you are in the space. So that's why you find in vacuum or in space or the vacuum room, a room in some places and institutions they test the vacuum and like this. So you find that no air resistance. That's why astronauts, okay, or people or astronauts in space, they appeal they are weightless. So they are weightless because actually there is no gravity. So as there is no gravity, you feel that they are weight and they could jump because here there is no force affect their body. So astronauts float in orbiting spacecraft because of free fall. What does it mean? Actually, here you're gonna find the spacecraft already they are moving. The spacecraft is under gravity of the whatever the planet they are rotate around the moon, whatever. So the spacecraft overall is under the effect of gravity of this. That means, for example, to show to you, hey, that's me. Just a minute. We said, for example, So for example here guys, that's the earth, and that's a space shuttle that already rotates around the earth or moon or whatever any planet is. As it keep rotating, there is a kind of gravity toward the planet, okay, whatever this planet is. So here there is a gravity, but here spaceship, okay, or the astronauts inside, they are under the effect of gravity, and there is no other force inside. That means there is no resistance because it's vacuumated or vacuum inside this. Because just wear their suits, which ensure them that they have oxygen and something, so no one asks how they are in vacuum and keep alive. So they keep floating. Why? Because they are under the effect of free falling. It is already rotated. It's under the gravity, and there is no other force that opposes their motion. So that's we call this. That's why they appear float in this case. Okay. So here, that's the idea, guys, how astronauts appear to float inside the spaceship or spacecraft. Okay, so here we said that the two motions combine to cause orbiting, or this spaceship to keep orbiting around the planet. That's because of two different forces they affect on it. What are these two different forces, or what is the problem here? Okay, so let's see together this part. So for example, this spaceship, as we see, it's rotating around the Earth. So we find they are under two different forces. The first force, that there is a gravity that start to pull the spaceship toward the planet itself. Okay, so it's a normal gravitational force. Like, okay, this, for example, this space shuttle was running around the Earth, so the Earth pulled it by gravitational force of Earth. In the same time, the engine of this space shuttle ensure the space shuttle keep moving forward. Okay, so it moves forward in constant speed because of its engine like this. So here we have two forces, and these two forces, well, they are not balanced forces. So we're gonna find they are gonna have a certain path in which it bends. That means a kind of direction between the two directions of these two forces, and that's which cause the space shuttle to keep orbiting. That's why if the engine of the space shuttle just doesn't work or like this, okay, actually it will fall down because it will be under just one force only, which is the gravitational force. And if the speed of the space shuttle was too fast or too more, or the power of the space shuttle was more than the gravitational force, it may escape of the gravity and just lost in space. So it's actually calculated to ensure that the two forces somehow have kind of integration to ensure that they could create this path in which the space shuttle will orbit around the Earth. So here we said that also this part is here we said that orbiting and centripetal force. So the unbalanced forces that cause objects to move in a circular path, we call this centripetal force. What does it mean? That mean here, as we saw in the last, that here we have unbalanced force because we have force in two opposite direction, and these forces of course are not equal. So unbalanced force create a new direction in which that will move in orbital. We call this centripetal force. So here, that's the definition. What is centripetal force? We said that it's the unbalanced force that causes an object to move in orbital or circular path. So gravity provides the centripetal force that keeps objects in orbit. That's why the moon keeps rotating around the earth, because the moon already under the gravity falls under the gravity of the earth, and in the same time it's rotate within certain speed. So like this, okay, it keep in centripetal, or the centripetal force keep the moon orbiting around the earth, and the same happen to the earth once it rotates around the sun. Okay, so here also that's create something we call the projectile motion. What is the projectile motion? Actually, projectile motion is just a curved path in which an object take while its movement, during its movement. That's happen when the object is not big enough, or or this object was not able to rotate around another object. So what is projectile motion here? Let's see together to ensure this. So here we find, I'm going to show you this part, okay? So this baseball player, when you just throw a ball, the ball is very, very small. Its size is very, very small, and the speed you apply or the force you apply on the ball is too small compared to the gravitational force of the Earth. So what we find the ball actually we will work or will be under two different forces. One force toward the ground, which is the gravity, and same force, the horizontal force, which represent your hand force that applied on the ball to move in this direction. So after a while, because of the air resistance and because the ball will lose of some its energy because of the air resistance, so its speed will slow down, and here the effect of gravity will show to or will increase gradually, causing the ball to take this curved path, which we call it projectile, and finally, of course, it will fall down when the gravitational force overcome your force at the end. So here we call this projectile. So projectile motion is concerned like a part of the centripetal force or like a part of orbiting. Okay, imagine that this ball is too huge and it has its own power that keep moving. That means it doesn't lose its speed. So actually, it will keep rotating in a state of falling down like that. Okay. So here, that's the idea of projectile, or that what I mean by projectile. So to just explain it here in details, so we said that projectile motion is the curved path on an object follows when it's thrown or propelled near to the surface of the earth. Projectile motion has two components, horizontal motion and vertical motion. What are these components? The horizontal motion is the amount that parallel to the ground, okay? While we find that when you throw the ball, your hand exerts a force. So that is the horizontal motion, your hand force which is applied on the ball. At the same time, there is a vertical motion which is due to the gravitational force that pull the ball toward the ground, and finally it leads to this curved path. Like this, guys, we already finished the first section in chapter 6. Study well from your textbook. If you have any question, you can ask anytime. Thank you and see you next time.